So, welcome to the starter solutions video for our radioactive properties lesson. So, the question I posed to you during the main video, which you will hopefully have answered, what is the difference between an atom and an ion? Well, the main difference is very simple, actually, but there's a lot of underlying things going on. So, in short, an atom is what we call neutral. What that means, which I'll write in another colour, sort of a longer form explanation, means it has no overall charge. Now, that's not to say an atom does not have any charges in it, because it does. However, all those charges cancel out and the overall charge of the atom is 0. Let me show you what I mean. So, this is going to be a model of a helium-3 nucleus. Now, normally these would be a bit more bound together, but that will do. So I have 2 protons and a neutron in helium-3, because helium has got 2 protons, its atomic number is 2. So that's my nucleus. Now, in a helium-3 atom, the overall charge is neutral. And each proton, you will hopefully know, possibly from even key stage 3, has a charge, relatively, of +1. So it is 1 charge each. So our number of charges is 1, 2. +2. Now, our electrons, which are going to be modelled by these things here, they have a charge of -1, relatively. So if I put them, this is not at all to scale, and probably not how you've been taught to draw a shell diagram, but it'll do. If I have my 2 electrons in an orbit around the helium atom, or around the helium nucleus to make a helium atom, I should say, then those 2 pluses and those 2 minuses cancel each other out, and the overall atom is neutral. However, if I were to add in another electron in the second shell, because the first shell is now full, if I was to add another electron in the next shell, then suddenly I've got 3 minuses and 2 pluses. So the overall charge is not 0, and my atom is no longer neutral. Or, if I was to knock one of these electrons off, I now only have 1 electron in the shell, then again, I have 2 pluses and 1 minus, so my overall charge is +1. My atom is not neutral, and that is an ion. So we say, essentially, an ion is charged. In short, an atom is neutral, an ion is charged. What that therefore means, from what we've just seen, is an unequal number of protons and electrons. I don't need to talk about neutrons because they are neutral, clue in the name. So if the number of protons and electrons is not equal, the overall charge is not 0. The atom is no longer neutral, it is charged, and so we call it an ion. That is the solution. Hopefully I've been able to model that for you as well. Right, let's get back to the main video, and that is also linked in the description if you need it, and let's get on to some radiation.